that I mentioned. So if I go back to Nmap, if you notice, the output is now ready. It basically has shown me the status of all the different IP addresses that are specified in the range. So pretty much all the IP addresses are down, or there is a firewall that is blocking access to all these different IP addresses, right? Now, to find out whether it's a firewall or whether it's actually a case where all these IP addresses are down, what you can do is, in the command, type -pn, and then you run the command again. So -pn will avoid using ICMP protocol completely and will still try to perform a ping sweep scan for you. So that's the beauty of Nmap, because Nmap gives you a lot of power and a lot of flexibility in terms of what kind of commands you can execute online. Let's see if NetScan tools has been completed. I think the scan is still going on, so we'll just kind of skip it, but all of you get the whole idea. Performing ping sweeping is actually not very difficult at all using these ready-to-use software like ZenMap, Angry IP Scanner, or NetScan tools. So that concludes the first information gathering tool, which is ping. Let's quickly move on to the next information gathering tool called traceroute. So what exactly is traceroute, and how is it different from ping, and what information about the victim does it reveal to us? So traceroute, like the name suggests, allows you to trace the path taken by data packets when they travel from your computer to the destination computer. See, whenever data is sent from one computer to another on the internet, the data never takes the same path each time. So each time you send data, say from your computer to your friend's computer, the path taken by the data may be different. So it's never the same. Now, how do you find out the path taken by the data? You need to use the traceroute software. Now, for you to understand what I mean by the path, it basically means that, okay, if I'm in Mumbai and you're in, say, New York in the US, if I send you some data from my machine to your machine, how will the data travel the world to reach your computer in New York from my computer in Mumbai? So from maybe my computer in Mumbai, it will go to the ISP that I'm using. So maybe I'm using, say, Airtel. So it will go to the Airtel server in Mumbai. And then from the Airtel server in Mumbai, the data might go to the Airtel server in Delhi, because that's where the headquarters are. And then from the Airtel server in Delhi, it might go to, say, some VSNL or BSNL server, where the backend broadband to Airtel is being provided by VSNL or BSNL. And then from that server, it will maybe go to somewhere in Europe, and maybe in London or Frankfurt in Germany or so on. And maybe from there, it will go to another server in New York. And then finally, it will go to your ISP in New York. And then from your ISP in New York, it will go to your computer. So that is how data is being transmitted from my machine to your machine. It never goes directly unless you and I are on the same internal network. So traceroute is a tool that allows you to trace the path between two computers in terms of what is the path taken by data packets when they are sent from one computer to another. Now, originally traceroute was used for network troubleshooting purposes, but nowadays it is commonly used for OS detection, firewall detection, network topology or topography information, and also to identify the geographical location of the target computer. So let us now see a very simple example or demonstration of traceroute. Just like ping, traceroute is also available as part of MS-DOS or as part of, if you're using Unix, as part of the shell prompt. So in Windows, you've got to type tracert, that is TRACERT, tracert, followed by the victim host name. So I want to trace the path from my computer to google.com. So let us see what path gets traced. So you'll just have to wait for a couple of minutes while the path gets traced. So if you notice, it is showing 5 or 6 different IP addresses already. So finally the trace is complete. So for data to reach google.com from my computer, there are 6 computers in between. If you notice, actually in the output there are 7 computers showing up. But the 7th computer is actually the Google server itself. So which is why, although it is showing 7 computers, you eliminate the last line. So there are 6 computers between me and the Google server. So whenever I send data from my computer to the Google server, it goes to 6 different computers and then it reaches the Google server. Now, just like ping, not only can you perform traceroute using MS-DOS, you can also use that website ping.eu. So let me open up ping.eu. And if you go to the home page of ping.eu, click on the traceroute button. And in this space provided, you can type in the IP address or the website address that you want to trace. So I'm typing google.com, press enter, and within a few seconds, if all of you look at the screen, the output has been displayed. But the output is actually very interesting because it showed me 5 entries, after which the 6th, 7th and 8th entry, you don't get an output, you just get a star or an asterisk getting displayed. So whenever you see something like that in a traceroute output, what it means is that you may have reached a firewall that is blocking the traceroute packets or blocking your traceroute command. So that is how you can use traceroute to detect the presence of a firewall on a remote computer. Now many of you might be wondering, when I use traceroute from MS-DOS, I did not reach a firewall. But when I use traceroute from ping.eu, how come there is a firewall? So the difference is that, please remember, ping.eu allows you to perform ping or traceroute from their server. So maybe from their server, while you're going to google.com, there's a firewall in the middle, which is blocking traceroute. But from my computer, when I perform traceroute using MS-DOS, there is no firewall between my computer and google.com, which is why I don't see any star or asterisk getting displayed. So that is the difference between ping.eu and MS-DOS command line prompt. So just like ping, traceroute is a very important tool in terms of getting information about a remote computer. So let us actually understand traceroute slightly better. This gets a little bit technical from a networking concept perspective, but even if you don't understand it, don't worry, because when we are doing a practical demonstration after this theory explanation, during the practical demonstration it will be pretty easy for you to understand this. Now, traceroute makes use of the following data packets to perform the tracing process. First of all, there is something known as time to live, or TTL value of a data packet. The TTL value of a data packet represents the maximum possible age of that particular data packet, after which the data packet is dropped. Now, a TTL value was originally created to prevent infinite loop of data packets on the internet. And the age of a data packet is determined by the number of routers or number of hops that the data packet reaches. So, if my computer is sending some data to you, the data will have a TTL value. Say the TTL value is 100. Now, whenever the data packet reaches a router, the TTL value is reduced by 1. So, on my computer, it may be 100. When the data packet reaches the first router, the TTL value becomes 99, then 98, 97, and so on. So, any data packet that is created by any computer has an initial TTL value. And whenever that data packet reaches another computer or router or hop, the TTL value is reduced by 1. So, similarly, each time it reaches some router, the TTL value gets reduced by 1. The second concept that you need to understand about traceroute is that it makes use of an ICMP time exceeded error message. It is generated when a computer receives a data packet with a TTL value of 1. And finally, it also makes use of an ICMP port unreachable error message. It is generated when a client tries to establish a connection with a closed port. So, for traceroute to work, it makes use of these 3 different types of data packets or networking concepts. So, we could actually at this point of time get into more networking details or networking concepts behind traceroute. But I'm actually going to skip it. If you are interested, you can always drop me an email, or online there are a lot of tutorials about the exact networking concept behind traceroute. But for the purpose of this course, or for the purpose of hacking, you don't need to actually know it. For your knowledge, yes, I would encourage all of you to learn it. But let me actually skip this particular slide and instead explain to you what is important from a hacking perspective in terms of how traceroute works and how ping works. So the concept that I'll try to explain here is something known as the TTL value. In fact, actually, even before this, let me take a step back. The topic of what I'm going to explain to you next is how to find out the operating system of a remote computer by using only ping and traceroute. So, in other words, how to perform OS fingerprinting using just ping and traceroute. So let us now quickly go back to the notepad file and understand this. Now, the main concept that you need to understand is TTL value. So what exactly is TTL value and why is it so important? The full form of TTL is time to live. Time to live value or TTL value. So that is the full form of TTL, and let me explain to you what it exactly means. I'm going to give you an example from real life. Human beings, on average, have a lifespan of, say, 70 years or 80 years. Which basically means that when you are born, you have a TTL value of 80 years. So whenever you are born, you have a TTL value of 80 years. And each time it's your birthday, the TTL value is reduced by 1. So birthdays reduce TTL value by -1, right? Or by 1. So what is your TTL value on your 10th birthday? It's 70. And what is your TTL value on your 20th birthday? It's 60. And what is your TTL value on your 60th birthday? It's 20. And then on your 80th birthday, your TTL value is 0 and you die. Right? So that's the concept of TTL values. From the moment you are born, you are given a TTL value, and every birthday, your TTL value is reduced by 1 until your TTL value becomes 0, after which you are discarded or you die. Similarly, you can apply the same logic to data packets. So every data packet that is created by any computer has an initial TTL value. So just the way when you're born, you have an initial TTL value of say 80, 70 or 100 or whatever your lifespan is. Similarly, whenever any data packet is created, it has an initial TTL value. Now, whenever a data packet, see, data packets don't have birthdays, but whenever a data packet reaches a router, you reduce the TTL value by 1. Just the way, whenever you reach a birthday, your TTL value is reduced by 1. Similarly, whenever a data packet reaches a router on the internet, the TTL value is reduced by 1. And then, when the TTL value is 0, at TTL is equal to 0, the data packet is discarded. Or it is thrown out. Or it is dead. So that is the concept of TTL values. Now, for human beings, the initial TTL value depends on what? That is, what is your initial TTL value? It's your lifespan. How long you live is generally dependent on your genes or your parents. They essentially, the genetics or genes basically decide how long you're going to live. For data packets, the initial TTL value or the lifespan of a data packet is also decided by the genes. And in this case, the gene is operating system. Operating system. So in other words, different operating systems have different initial TTL values that they assign to data packets. So if I am a Windows operating system, and if I create a data packet, maybe the initial TTL value is say 100. But if I am a Unix computer, the initial TTL value may be 60. So the initial TTL value of a data packet depends on the operating system that created the data packet. So if I am a criminal and if I want to find out your computer's operating system, I can find out your initial TTL value or the initial TTL value of data packets that you have created, and then based on that I can find out what your operating system is. So that is why TTL values are so important, because TTL values will allow a criminal to identify the operating system that is running on a remote computer. So let me now give you an example of how to use ping and traceroute to find out initial TTL value of a data packet sent by a computer, and hence find out the operating system running on a remote computer. So using ping and traceroute, I can find out the initial TTL value of data packets sent by any computer, and once I know the initial TTL value sent by a particular of data packets sent by a particular computer, I can actually then find out the operating system that is running on that computer. So let us see an example of this, right? Let's assume that I want to find out the operating system running on imt.edu. So what do I need to do? Let me first perform ping. So step 1, you need to perform ping. So let me open up MS-DOS and I'll ping imt.edu. I press enter, and within a few seconds I have gotten some kind of response. So let me actually try to copy paste the result, and I'll just copy paste the important part so that all of you can see the screen properly or see the results properly. So this is the output that we have received. Let me copy paste it into Notepad. So when we perform ping on imt.edu, this is the output that we got. Now if you look at the output very carefully, do you see anything that is interesting? There is something which says TTL is equal to 117. Every line has that. TTL is equal to 117. So using ping, we were able to find out the final TTL value of data packets sent by imt.edu, because here ping has recorded the reply that it has received from imt.edu, and the reply, the data packet which is the reply, has a particular TTL value which is the final TTL value, which in this case is 117. So let's make a note of it, right? Next step is we need to use traceroute or traceroute. And once again I will use MS-DOS to do a traceroute on imt.edu. So I type traceroute space imt.edu. So let's wait for the response. This will take a couple of minutes, so you'll have to be patient. So if you notice, the response or the trace is complete, and let me once again copy the output. I'll copy paste it into Notepad. So this is the output that we got. So how many routers are there between my computer and IMT? It says 8. But the last is usually the actual website. So in total there are 7 routers. So traceroute gave me the number of routers between me and the victim, which is 7. Now, the rules that we have learnt is that whenever a new data packet is created, there is an initial TTL value. And when does the initial TTL value reduce? Whenever it reaches a router, it reduces by 1. And then finally there is a final TTL value. So in this case, we know the final TTL value is 117. And we know that the number of routers are 7. So then what is the initial TTL value? So it's a simple formula. Initial TTL value minus number of routers will give you final TTL value. So let's plug in the values. Initial TTL value minus 7 is equal to 117. That means initial TTL value is equal to approximately 124. So the initial TTL value of imt.edu is 124. And now step 3 is find out OS running on imt.edu. So how do we do that? You can